This short demonstration will showcase the broad yet easy-to-use data integration capabilities of Cambridge Semantic's Anzo platform. Imagine that the front office of a prominent Major League Baseball team wants to have a 360-degree view of all aspects of the organization, ranging from statistics about their players and other players in the league, the health and injury status of their current players on the roster, or even news articles about those players and things that are being said about them. To do this, we have to integrate data from many sources, including relational databases for our statistical data, spreadsheets for the on-the-fly data created by members across the organization, such as health personnel, and news sources, such as Google News, to get the latest news about our baseball players. We're going to show how to do this very easily in a few short steps. The backbone of any solution in Anzo is the ontology, or high-level data model. These ontologies are data models that represent the data in the way that users think about it, not the way a database or XML file or even a spreadsheet thinks about the data. So interacting with that data model and even creating it is going to be very natural for business analysts and not technical people who just understand their data. So let's see how that works in Anzo. In Anzo, our ontologies are edited in the Anzo ontology editor, which is in our Anzo for Microsoft Excel plugin. As you'll see, the Anzo for Microsoft Excel plugin serves as sort of the main workbench where a lot of the data mapping, data integration, and data interaction tasks take place in Anzo. So let's just take a quick look at our baseball ontology, which will sort of guide how we look at data through the rest of the demonstration. We have many simple concepts like game, league, player, and team. And within those, you have properties such as the debut date when a player started playing, their first name, last name, full name, or even a unique ID to identify that player. The game concept, or class, is a little bit more complex. It has properties like attendance, the date the game was played, relationships to the home lineup or players that played in that game, the home starting pitcher, the team, runs scored, and many other properties that you would expect to see possibly in the line score or box score for a baseball game. So now that we've seen the ontology, let's get started with the actual solution. The first part we want to show is what does a dashboard look like? And this is sort of going to be the launching point for our 360-degree view of our baseball team. So we're going to start by logging into the Anzo on the web platform. I'm going to log in with my user Ben. And I'm going to search for existing dashboards. My Major League Baseball game statistics platform is available to me. And as we can see, there isn't really any data available yet in this dashboard. So far, we just have some reference data loaded about what players are playing in the league. So let's now go out and get some real statistics to start populating our dashboard. For that, we're going to use the Anzo Connect product. So I'm going to connect to my Anzo server, type in my username and password, and now I'm connected to Anzo by the Anzo Connect product. So the first step once we're connected to Anzo is to identify the relational database that we want to connect to and pull data from. So this is going to be our Major League Baseball statistics database. And the database that we are going to be pulling data from today is an Oracle database, although we do support a wide variety of relational databases depending on the particular use case or customer. So I just specified the login information from our relational database, and Anzo will handle all the connectivity to that relational database for me. And this is really critical when your relational databases and other data sources sit behind firewalls that users from their workbenches and laptops might not have access to, but they can get to Anzo, and then Anzo can in turn get to all that relational data for them. So we've tested our connection, and now the next step is to configure which schemas or table spaces or sections of the database we want to include. This is different for each database, but in general, Anzo Connect will display a high-level description of the types of data that are available in the database for the user to make their selection. So we're going to choose Major League Baseball as our, in this case, it's a schema from Oracle. And Anzo is going to query the database catalog, pulling all the relevant tables and columns and schema information down into Anzo, storing it in a semantic format in Anzo, and using that to help drive the rest of the data integration process. So now we can start adding some queries which will define how we pull data out of the relational database. So in this query editor, we see we have a few different tables available inside of our Major League Baseball schema. So I'm just going to start dragging those queries onto our palette here, and it automatically starts building a query for me down below. So you can use a combination of the UI to do things like dragging tables onto the palette, connecting things, adding constraints, but it's also possible to modify the SQL directly. That's pretty easy to do with the type of head assistance provided by the editor. So here I've selected all the MLB games data for one particular team. In this case, it's the American League team from New York, the Yankees. And we can check to see the results of this query. So Anzo is going to issue that query to the relational database for us, ship the results back to our workbench here, and we can see if this is the data that we're expecting to get. In this case, it looks fine. So we're going to go ahead and use this query. We'll give it a reasonable name. This will be my games query, or maybe we'll just call it games. I go ahead and save that. Now we want to add a second query to pull in information about what players are playing in which games. The actual database that we're working on here actually has some very advanced statistical data, drilling all the way down to bat by bat and pitch by pitch data. But for this simple demonstration, we're just going to look at the games and the players who played in them. That should be a good example. So when I dragged in this second table here, it automatically did the join based on game ID and the foreign key relationship that is exposed from the relational database through Anzo. And I can also modify this query to add some additional constraints as well. Now I can test this query as well and see that I'm getting back some results. In this case, however, I just want to select 4 of these columns, and now it looks exactly what I expect to see. I can give this query a name. We'll call this the lineups query, and I'll save it. What we've done so far is decided what data we're pulling from the relational database. We haven't actually introduced semantics, and we certainly haven't mapped the data from the relational database to our ontology or central data model. And so that's what we're going to do now. So Anzo Connect is going to query the relational database for us based on the queries we specified and bring just about 100 rows from each of the queries into Anzo for Excel to drive the mapping process. Now it's important to note here that we're not simply bringing data into Excel and then loading that data from Excel. We're using the Anzo for Excel plugin here just to associate the mappings with the queries. We're not actually loading this data that we're looking at here. This is just sample data. So again, the first step is to log into Anzo. What we want to do now is link the data model that we looked at earlier, so the high-level concepts for games and lineups and players, to the data coming from the queries here. So I'm just going to choose the data set or where I want to put the information about these games and their players. And that's going to go in the games data set. I choose the game type. Now I start selecting properties from my ontology that correspond to the columns of information coming from the query. So we have retro sheet ID corresponds to game ID. The player is a link to the player that resides inside the home lineup type. Now one thing that's interesting to note here is that the players already exist inside of Anzo in our player data set. So we choose the player data set or the people data set as the data set where we want to look up and find those players, and we specify the retro sheet ID as a search key that will mean that it's going to use this property value to try to look up existing players. This will keep us from having duplicate data or linking to incorrect players. Now we can complete the mapping by mapping these 2 simple data properties, batting order position, which is sort of the position in the lineup, and the fielding position. When we're done, we can review the mapping. In this case, we just had 4 columns, and click Map. Anzo for Excel gives us the opportunity to save the mapping, and then it will tell us that that mapping has been applied. Peeking back at Anzo Connect, we can see that 1 of 2 of our queries have been completely mapped. To complete the second query, we'll notice that this one has about 20 or so columns, so we don't want to go through that in detail here. But fortunately, we already have an existing mapping that knows how to deal with this structure of data, so we're just going to apply that mapping and review it to make sure that this is indeed the mapping we want. I can click on a particular property and it'll highlight in green the column that has been associated with that property. This is a pretty straightforward mapping, but there are actually a couple things worth pointing out here. If you'll notice in column B, we have a date that represents the date that the game was played. Now, the format that the Oracle database chose to use for the date isn't terribly compatible with how Excel thinks about dates. This is just a 4-digit year concatenated with a 2-digit month and a 2-digit day. Now, Excel will not identify this as a proper date. Fortunately, Anzo for Excel and Anzo Connect allow us to specify transformations on the data as it's loading in. In this case, we've made use of a regular expression to pull out the key parts of the date and recombine them in the right format. Another type of transformation that's available for those who are not familiar with regular expressions are the familiar Excel formulas. In this case, we use an Excel formula to translate the time value in column C to a proper time that can be recognized by Anzo and Excel as a semantic time. So once I've reviewed this mapping and I'm satisfied that it is indeed what I want, I can go and click on Map. And now it's been applied. So now we can see that both sheets of this query have now been mapped. And now we're ready to save the mapping. And when I do that, it combines the queries, the mappings, and any other configuration settings that I've done here into a service configuration that gets stored into Anzo, and then that automatically deploys a service endpoint that we can then call on a scheduled basis, on an incremental basis, or even on demand, as we're going to do right now. So I go ahead and click Run. I can choose all of the queries that I want to run and click Start. So as these queries run, we can see progress on a batch by batch or row by row progress of the mappings. We can see how long the last batch took, we can see average batch time, we can see how many batches have been completed to get a sense of how long the process is going to take. The second query, lineups, is a bit longer. It has about 8,000 rows. Now, we could watch that data loading in here, but a more interesting way to see it is if we go back to our Anzo on the web dashboard, we can see that the data is already starting to fill in here in our dashboard. So we can see this chart has now filled in based on the pitchers that played in our games and the number of runs that they allowed. This chart is showing the average number of runs allowed by starting pitchers. So we can see the most effective pitchers are going to be toward the top and the less effective pitchers toward the bottom. Now that the data has been loaded from the relational database, our dashboard that we looked at the beginning of the demonstration is now nicely filled with data. So now that we've loaded data from a relational database, let's move on to the next part of the scenario. Suppose that the head trainer for the New York Yankees is keeping track of the injuries and disabled list status for their players in a spreadsheet that he keeps locally on his laptop. Now, on an almost daily basis, the general manager of the New York Yankees wants to know which players are injured and which players are performing well so he can make decisions about who to call up from their AAA affiliates in order to fill spaces on the roster, or who they need to go out and make trades for to fulfill positions for more longer-term injuries. So let's see how that might work. Going back into Anzo for Microsoft Excel, we're going to start by creating a fictitious spreadsheet that you can imagine somebody using to keep track of baseball players' injuries. So maybe we have a player, maybe have a description of the injury, maybe the severity, and the number of days disabled. So now we have a sample spreadsheet with relevant injury information that we'd like to include in our solution. At the moment, we don't have anything in our data model that knows about injuries, so let's add that really quickly. Let's pause for a second though and think about what it would take to add this into a relational database. You'd have to update the schema, possibly reloading tables that had been modified. You'd have to update the data access layer and regenerate business objects, and then make custom changes to the UIs in order to take advantage of all that. In optimistic terms, this might take 1 to 3 months, but in all likelihood, you're looking at 6 months to a year for changes like this, especially in production enterprise systems. And if it's just a simple use case that somebody wanted to do, it probably wouldn't get done because the cost would be too prohibitive. Let's see how long it takes now. First we want to do is create a new concept in our ontology to model injuries. So we create a class called injury. Next, we want to create a property to associate injuries to the player that was injured. I choose the type of the property, as player, and that creates a relationship between injury and the injured player. Now we have a few data properties that fill out the details of the injury, such as the description, the severity, and the days disabled. For severity, we might want to actually control the set of values that are allowed to be used for that property. For instance, perhaps the only possible values are mild, moderate, and severe. So we don't want to let people put in things like medium, which would make the data not clean. So let's see how we do that. We'll create what's called a pick list, which is a set of allowed values that can be applied to a particular property. So we'll call this injury severity. So mild, moderate, and severe. And now we want to apply that to this property. Let me search for the pick list that I just created. There it is. And now we've constrained what we call the range of this property to just the values that we think are valid. So to summarize, we created a small addition to our ontology that captures injuries. We have a relationship to the injured player, a description of the injury, a controlled vocabulary for the values of the severity of the injuries, and the number of days that this player is expected to be disabled. Now that we have that, we can actually go and now link this spreadsheet into our solution. So again, we're going to click on link. We're going to choose the data set of people, choose the concept, which in this case is injury, and now apply the properties from the injury ontology class to our spreadsheet. So I'm going to double click on injured player. Now we don't have an ID property like we did when we were linking the database data, but we can use full name as a pretty good unique key in order to look up the player that in this case is injured. Now we can map in the description, severity, and finally the days disabled. When I'm done, I just click link, and it's going to look for the existing players and try to upload that data. It didn't find a player named Jorge Posada. Oh, that's because I misspelled his name. Let's see what happens when I correct it and research. Now I see the value of the correct player. I can double click on it and it will create the proper link. So now we've loaded the data into Anzo, and the spreadsheet now is actually live linked, and we'll see how that works in just a second. So now let's try to combine this new injury data that we just loaded in with our existing 360-degree dashboard. I can navigate now through the ontology and we'll see the new concept of injury that has been added to the ontology. When I click in here, we see the list of values that pertain to injury. In this case, maybe we just want to display the description and maybe the number of days disabled in this table. We also might want to filter through the data to see only those players that have an injury of a certain severity. So let's go ahead and see how to create a filter. Just like choosing properties from our table, we're able to browse through the ontology and pick the property that we want to filter on. In this case, it's going to be the severity of the injury. We can see that there are 2 mild and 1 severe. But because this data is live linked, we can actually change the data in Excel and have that reflected instantly in our dashboard without having to email this spreadsheet around. Let's see how that works. So suppose that Jorge Posada's condition doesn't improve and they decide to update his condition to moderate. We can see by changing it to moderate that Jorge Posada now has a moderate injury, and that data is immediately reflected in our dashboard, and that is because the data is both live linked to the spreadsheet and the dashboard is live linked to the data in Anzo. So to recap where we are now, we started off with a relatively empty data set. We brought in some statistical data from a relational database that initially populated our dashboard's hero statistics. We then augmented that dashboard with information coming from one user's spreadsheet containing information about injuries. The final step is to bring in information from some unstructured data sources. In this case, it'll be some news articles about baseball players. So to do that, we're going to use the Anzo unstructured product. Anzo unstructured allows users in a self-service way, just like we've seen with the Excel tool and the dashboards in Anzo Connect, to bring in data from unstructured sources just as easily. Anzo unstructured allows users to configure pipelines. A pipeline has 2 basic stages. The first stage is crawling or intake. This is where the user determines the corpus of unstructured data that they want to process. For example, a set of news feeds, some documents on a local file system, an email account, or some Twitter hashtags that they want to follow. The second stage is to determine what text analytics tools they want to apply on top of that unstructured data. Sometimes these will be simple entity extractors or basic annotators that might come prepackaged with Anzo Unstructured. Or it might be a best-in-breed text analytics tool that they have specifically licensed and has been integrated into Anzo Unstructured. Either way, the process will be simple configuration like we've seen with the other parts of the Anzo stack. Let's see how that works here. So the first step is we want to give our pipeline a name to describe the kind of data that it's loading in. In this case, it's a pipeline for processing Major League Baseball news. So the first step is we're going to configure a crawler, or again, the source of unstructured data that we're interested in. In this case, we're going to be crawling a Google News feed for information about our baseball players. Now, we don't want to ingest every single article coming from Google News, both because they're not all relevant to our solution, but also because that's probably a heck of a lot of data that we don't want to index and store locally on our server. So we're going to configure our news crawler to consider only those articles that mention any of our baseball players. And the way we do that is by specifying the data set containing the entities that we want to consider. So in this case, that's our people data set. The ontology is the baseball ontology. And we choose a predicate that we want to use to match on. In this case, I think the name of the player will do a good job. So far, we've configured what data we want to consider. In this case, it's any news article that mentions our baseball players. Now the user gets to choose what text analytics tool they want to apply to the data that's been ingested. In this case, we see the list of services and annotators that are provided out of the box with Anzo Unstructured. This includes OpenCalais from Thomson Reuters, Viral Heat Simple Sentiment Annotator, as well as a set of simple annotators that can be configured here. This interface will also contain options for any third-party or specially licensed text analytics tools that the customer may have licenses for. But we're going to use the knowledge base annotator, which will allow us to annotate or mark up the articles that we're ingesting based on the players that we have in our knowledge base. So the first thing we want to do is we want to give our particular configuration of the annotator a good name. This will be our MLB player annotator. And now we want to choose what entities we want to look for in these documents. Now that's of course going to be our baseball players. So just like we configured our crawler to consider our baseball players, we want to do the same with our annotator as well. Before we can continue, we want to validate our pipeline to make sure that we filled in all the required configuration information. So we click Validate, and Anzo Unstructured tell us that everything validates fine. So now we want to run the pipeline. So we go back to our Unstructured Pipelines dashboard. We can see our new pipeline is now available in the list. We click on the status to bring up more detailed status about what the pipeline is doing. When we run the pipeline, we'll begin to see documents flowing through each tier of the pipeline. The first stage in the pipeline is crawling, where the documents are entering into Anzo based on the configuration of our news crawler. We then store them securely in the Anzo binary store, extract relevant metadata, full text index them for search, and then on to the meat and potatoes of the pipeline, which is where we do all the text analytics processing and entity extraction. That takes place in the annotation framework. As you can see, each tier has a number of threads that are available for processing. This is because different stages of the pipeline are going to be more intensive for processing based on the configuration. Once annotation has been completed, it goes on to post-processing, which includes mapping the data that's found by our text analytics tools onto that same central ontology that we were looking at in Anzo for Excel. Finally, after the post-processing is completed, the documents end up in the hopper. Now that a number of documents have flown through our pipeline, we'll go and create a dashboard to visualize the results of the unstructured data processing. So we're going to create a new dashboard, and we'll call this MLB Players in the News. And the first start of building any dashboard, whether it's for unstructured data or statistical data like we saw in the game statistics dashboard, we want to choose the data sets that are going to be included for visualization. So in this case, we're going to be linking back to games and people, but primarily the data is going to be coming from this MLB News pipeline corpus, which is a data set that was created for us automatically by the Major League Baseball News pipeline. Once we've chosen our data sets, we want to choose the type of information that we want to render. In this case, we're creating a document-focused dashboard, so I'm going to search for unstructured document and select it. Now we want to create visualizations of the data. There are a number of different ones we can create, from lists of metadata about the documents, which we'll do now, to actual real visualizations of the text in its original form. Let's create a simple table to start off with that'll show basic metadata about the articles. We could use the property browser to choose the individual properties about the document that we want to include here. But as a shortcut, we can just click the little gear icon here, and it'll select a variety of properties to include in our table. It's a good way to get started if you're unsure of what's included in a particular ontology. So here we can see the metadata about a number of different articles that were produced from Anzo Unstructured. But perhaps now we want to filter this down. We can do that in a number of ways. First off, perhaps we only trust articles coming from a particular source. So let's create a filter on document source. I'm going to select ESPN and the ESPN blogs as two examples of trusted sources of documents that we care about. Next, maybe you want to filter this based on some characteristics of the players mentioned in the article. This is an example of how Anzo Unstructured links unstructured data to structured. In this case, we're browsing basic metadata about the document itself, but we can navigate out of that realm through the ontology to link to the player that is actually mentioned in that article. From here, we could display information such as the player's name, teams that player played for, positions they've had, or any information that's linked through the player, because now we're actually linked directly to the player concept. In this case, we're just going to use player full name. And so now I can filter down my articles based on the players that are mentioned. I can click more to see an expanded view of all the players that have been pulled out. Let's choose Derek Holland. So now we have 4 articles from ESPN that mention Derek Holland. Now we want to actually look at the text of these articles and see what information was extracted from them. So we're going to open up another lens. And when I search for lenses, it's searching for anything that knows how to render documents. This includes the articles lens that we just created and is already open. We also have the document lens, which will allow us to visualize the document. Let's first rearrange the layout of the dashboard so that we can show the list of our documents together on the same screen with the document that's actually selected. In general, the layout of Anzo on the web dashboards is fully customizable. In this case, we're choosing a simple top-to-bottom orientation. By selecting an article now from my table, I can affect which article we're actually looking at down below. So we can see in the text of the article, Anzo Unstructured has identified the places in the article where our baseball players are being referenced. We can see here on the right a legend indicating which annotator corresponds to which color of highlighting in the document. If we'd applied other text analytics tools here, we'd have additional entries here with additional colors. The final stage of this demonstration will sort of close the loop on how we've linked together the structured data and unstructured. So let's revisit our Major League Baseball game statistics data set, which was providing a 360-degree view of our players to the front office of the New York Yankees. The GM now can see the players that have played the most, wins and losses by pitchers, as well as their current injury status. Let's suppose now we want to integrate the news articles that we've already searched on based on the players. So just like we added other columns of information for the statistics that we currently have, we can also add a column of information for news articles. So from the player, we can actually navigate through the ontology to documents that reference that player. And we can pick any of these document properties, but maybe we can use the document's original location so that the person using this dashboard can get a link to the document to go and read the full text on the web. And so now we've added a column that contains the URLs of certain articles that relate to our players in our Major League Baseball dataset. This concludes our demonstration of the data integration capabilities of Anzo. Thank you for your time.